Okay, so good day, everyone. Today, welcome to the case study. So we're going to be analyzing a data set, and this data set deals with motorcycle data. That's for a particular organization that sells motorcycle parts. So once we analyze this particular data and also try and get insights from this data. So first of all, now we need to load some libraries. So libraries allows us to work with some functions which are not available in Python by default. So some functions are created and you can only access these particular functions using libraries. Such libraries are NumPy, and we also have pandas, which is used for data analysis. So, but you need to have those libraries installed in your local machine for you to be able to use it. So now I'm going to go to my Jupyter home, and I expect you to also go there. And under new, you click on the new button, you're going to see terminal. So when you click on terminal, you're going to have your terminal opened, just as you are seeing now on my screen, your Windows PowerShell. Then you're now going to type the command which you are going to be using to install a particular library. So I'm going to be using conda install. Conda install, then the name of the library follows. So currently, I want to install NumPy, use conda install NumPy. If you want to install pandas, use conda install pandas. If you want to install matplotlib, use conda install matplotlib. So these are the three libraries which are going to study. So the command is just conda install NumPy or pandas or matplotlib. So what goes last is just the name of the library. So once you just run the command, I already have it installed. That's why I'm not running it. So once you just run the command, it's going to install it. It's going to install everything for you. So let me just try that of the NumPy. By installing it again, it's going to update it. So you can see that of the NumPy is installing. It's collecting package metadata. So sometimes it takes a little time, especially if the package is heavy. So it's already done. So the same thing also you can apply it to also on the other libraries. So I don't know if you are getting that study, Damola.
Yes, sir. I'm getting that. It's just that
Are you
I'm
able
not
to?
with my system. I'm just watching from
Okay,
the
okay. No
from the
problem, no
phone.
problem. You can follow it on the, you can follow it.
I'm
Follow the
I'm I'm
recording.
I'm with you, sir.
Okay. So now back to our home page now. So currently now you can see this is the code we are going to run to be able to work with this particular data. To be able to work with this particular library. So the first is what matplotlib inline. So what this actually does is that anytime we make a plot, if we don't run this particular command, then that particular plot will open on a new tab. But if we run this, then all our plots are going to be run on a new cell that's just below the code that we're using running that particular plot. So matplotlib inline just allows your plots to be displayed in the notebook and not outside the notebook. That is not on a new window. We also have the import NumPy as NP. So why, if you type functions in the NumPy library, the same thing also applies for the pandas library. Import pandas as PD allows you to be able to access all the functions in the pandas library. So you can make use of all the functions in the pandas library, making use of this particular keyword. So we are importing the NumPy as NP. Sometimes the pandas can be P, but the normal convention, the usual convention, which you'll be seeing in everyone's code is NP, and for pandas, they're going to be seen as PD. So now I'm going to run Control Enter. By running Control Enter now, so you can see now by running Control Enter, I've already loaded this particular libraries. So now what we want to do next now, I want to read in the motorcycle sales data. So now you can see a function now here, read CSV. So this function allows us to be able to read CSV files. So CSV files are comma separated. separated values. And what I mean by comma separated, that is they are separated by comma. So let me go back now. So currently it is stored on the desktop, then Python. So this is the data now, sales.cs. You can see it here. So it are separated by what commas. You can see it. You can actually what edit it in this place. So you can see that these values are separated by comma. So this is from this format it gets its name, comma separated values. So you can see the headings in the next line are what the values, and they are both separated by commas. So now we already know the function which we can use to read the function now. So what I find you, this sales data is in the same directory as our Jupyter notebook. So that is why we're only calling it by the name sales.csv. Assuming this sales data was in another folder called data, we need to give the folder name first, then we now give the the name of this particular data. But currently now, they're both in the same folder directory. So I'm to use the word rich CSV for us, word rich CSV is not defined. Why? So which means for us to be able to access the rich CSV, we need to use the PD keyword. So this rich CSV belongs to the pandas library, which this dot is what's going to be connecting the library and the method together. So anytime you use a period, use operation you apply on an object is called a period. Now you can now state warehouse, clients type, product line, quantity, unit price, total, and payments of motorcycle transactions. So on the 1st of June 2021, a transaction was made at the central warehouse, and the clients that bought that made this transaction was a retail client, and the product line, the product he bought belonged to the product miscellaneous product line, and the quantity of items bought was 8. The unit price of each item was 16.85, and the total price, which is actually unit price times quantity, is 134.83. And the clients made a payment by credit card. So this follows for all transactions in this place. Currently, I can see we're having 1,000 rows times 8 columns. So which means our variables or our columns are 8, and the number of transactions that was made is 1,000. But mind you can see the indexing is showing up to 9999 because the Python indexing starts from 0 and not 1. So that is why the row index stops at 999, but the actual that's clear, Mr. Adidamola. Okay, so now we can make use of this particular data now as we are looking at it. So we need to be able to store this particular data now in a variable so that we can be able to use it throughout our notebook. So this is where you now use what? Sales. We call it sales is equals to pd.readCSV. So by calling it sales now, I've already stored all these words. I've already stored the data or the data frame into a variable called sales. So now we can now call sales, and we have our data sets. So you can see our data sets. But now if you notice now, you can see it's only showing us the top 5 rows, and it's also showing us the bottom 5 rows. So you can see that other values in between are hidden. So this is because it cannot actually show us all our values. So we just have to reduce the values so that we can just have a glimpse of our data sets. But what if I want to just see my top 5 rows? This is where I use the sales.head. So I'm going to be using the head method on the sales data frame. So mind you, is not in all objects. So we're going to be using the sales.head. So if I run the sales.head, I get the top 5 rows by default. So without putting any arguments are what allows you to be able to tune your function to your specific need. So without putting any arguments, I can now get what? I'm going to be getting 5 transactions here. What if I'm to use 10 in the brackets? So I'm going to be getting 10. You can see I'm going to be having 10 transactions. So I'm having 10 rows, which are 10 transactions. So this, any value you give here allows you to be able to specify the number of transactions you want to be showing from the top. Why? If you want it to be showing by the bottom, so the bottom 5 rows by default, that is tail, use the tail keyword. And when you run this, you see you're going to be having the bottom 5 observations. The same thing also applies if I'm to give a value of 20, I get the bottom 20 transactions, as you are seeing it now on the screen. So the sales.head and the sales.tail. So that's what is going to what is going to come before the head or the tail is actually the name of your data frame. So now the sales.head gives me the top 5 rows by default, while the sales.tail gives me the bottom 5 rows by default. Any value now inside the tail or the edge rows that is in your data frame. So now, what if you want to check the data types of the data? So you can, if you notice one thing now about the data frame is that the data frame consists of various columns, and these columns can be of various data types. Currently, now you can see we have numeric data type under total, numeric data type under unit price, and also numeric data type under quantity. Now, if you now check that of payment, you can see we're having text data type, product lines also text. So which means a data frame can contain different columns of different data types, but under each column, all the values in a column must be of the same data type. So you cannot be having under total a numeric value and also be having a text value. So it's not possible. Each column must be of the same data type. Total must be numeric, all true. Payment must be text, all true. Even if we're having numeric value safe inside this place, it's going to be converted to a text. So automatically it's going to be converted, it's going to be regarded as a text and not a numeric value, which means you cannot perform a calculation with that particular value. So that's what you should know, that data can contain various columns, and this column can be of various data types, and also each column must contain, the values in each column must be of the same data types. So now, how can we now check for the data types of each column? So this is where you can now use the sales.dtypes method. So the dtypes method allows you to get the data type of each particular column. So when I run sales.dtypes now, you can see that under dates, I have objects, warehouse, I also have objects, client type objects. So this is like just the general data types for text or maybe dates. While under quantity, we have integer, you can see it. Unit price, we have floats, we have total, we also have floats. If you notice that the integer are those without decimal points, which I was explained in yesterday's class. So now, what if you now want to know the number of rows that you're dealing with or the number of columns that you're dealing with in your data sets? So this is where you now use the sales.shape. So the sales.shape allows you to be able to view the number of rows first, then the number of columns. You can see we have 8 columns and 1,000 rows, which means we have 1,000 transactions. So the shape method allows you to get what the number, your data frame dimension. What is the dimension of your data frame? The number of rows and also the number of columns. Now, also, what if you have a very wide data set? You are talking of a data frame that is having, let's say, 50 columns. You now want to know, because if we have 50 columns, you cannot just view the data and say you want to be following or you want to be scrolling to view this column. So it's much easier columns, but there are some data frames where you're going to be having more than 8. So you can be having up to 100 columns. So how can you now get the column names in your data set? So this is where you now use the columns method. This columns method, you're going to be applying it on the data frame sets. So when you now run this, you're going to be having the list of all the columns in your data. And yesterday, we discussed about lists. So you can see that this particular result is stored in a list, which means you can index it. So if I'm to save it as a variable, now I'm calling it my column names. I can just call it column names is equals to sales.column. Now I will now index a particular column names here. So let me just index the third column names so you can see which is client type. So when you now run it, everything is going to all the lists, all the items here are going to be the list of your column names. If you don't see a column name here, then that means that column name is not. If you don't see any column name here, then that means it is not in your data frame. And if you see a column name here, then that means you have a column in that particular data frame. So this is the list of all the columns we are dealing with in the data, and it's according to the way it was arranged in the data. You can see dates, warehouse, client type, product line, quantity, unit price, total, and also payment. So now, how can you now get how can you now index, or let's say how can you now subset your data? So you want to get the first 5 rows of a particular column. So now it's not as if you are interested in all your data. You want to get the first 5 rows, but just for a particular column. So you also use the square bracket, just like similar to what we discussed about in dictionaries. So now let's say I want to access payments. So now by running only the sales payment in bracket, I get all the observations under payments, but only for the column what payment. You can see what I have, all the observation under payment, but only for the column payment. So now, if I now want to also get only for the top, I want to get only for the top 5 rows now. So I'm going to use So I'm now going to use the second, another 0. I can see 0 to 5. So you can see it now. This is the top 5 transactions under payment. So this is only for payment. So what if I'm to change this payment now to warehouse? You can see I also have the same thing. So currently I'm only accessing a single column. And now the other square bracket which I'm also giving is now allowing me to pick the number of rows I want. So this is how you can subset a particular column or subset a particular row. But we also have specially designed functions which is meant for this, which you can also use to you can also use to subset your data to subset from your data frame. So this brings me to the iloc method. So the iloc method, from the name iloc, allows you to be able to index your data frame either from the column or the row using the index number. So now you cannot use the column name in an iloc. So now let's say sales.iloc now. So sales.iloc now, I want to access all the rows in my data sets. And after accessing all the rows in my data set, I only want to access column 1 to 3. So column 1 is going to be carrying index number of 0, so which is going to be 0 towards column 3. So column 3 is going to be carrying index number of 2. So I'm going to keep 3 here and run this. So mind you, you know that this column, that this upper bound will give, is not going to be showing the data. So if you want this column, the fourth column, to show, which is the one with the index of 3, they're going to be using 4. So you can see now we're going to be having you are going to be having the fourth column with index of 3. So it's always important to keep in mind that indexing starts from 0. So you always know that, okay, if my indexing starts from 0, then that means the third item is going to be having an index of 2. The fourth item will be having an index of 3, and so on and so forth. So now this is how the iloc works. So it just deals with the index of both the columns and the rows. So now this column allows you to be able to access all the rows or all the transactions in this particular data frame. And the same thing too also applies if I'm to use this particular column here. I get all my data sets. You can see it. I get all my data sets. So this column symbol now allows you to access all the values both in your rows and your column. So now what if I'm just interested in only the first, let's say the first 10 rows. So I'm going to give it as this. You can see it. First 8 rows, sorry. So the first 8 rows now, you can see what I'm having, or 9 rows. This is supposed to be 9 rows. So the first 9 rows now, which I've already subsetted, you can I've already subset from the data. You can see it, and I can actually create a variable out of this. So I can just call this now subset. Let's call this now subset is equals to this, and this is already a new variable on its own. So sometimes you are not going to be working with all the data frame. You just need some pieces of information from the data frame. So this is how you can subset it. Then the next is going to be the lock. So the lock allows you to be able to now use your column names to index or subset here from your data. So now let's say I'm going to be having I want to subset for, okay. So let's say I want to subset all my transactions now, but for what? Only for dates. I'm just going to use dates. So you can see it now. This is a subset of all my transactions only for the dates column. So you can see all the values I'm having now only for dates. So what if I'm interested in only the top 5? I just say 0 to 5. So you can see what's the top 0 to 4. So you can see what's the top 5 now. You can see the top 5 under dates. If I also want to include another column, I can give the name of the column. I can call it, let's say I want to include warehouse, or I want to include client type. So you can see it now. I've already subsetted. I've subsetted only 3 columns and just 5 rows. So this is different between the iloc and the lock. So the lock allows you to be able to access your columns by their names, while the iloc allows you to be able to access your columns by their index value. So is there any question before I continue?
Not at all, not at all.
Okay, that's good. So now, what if I want to sort my data? So if from my sales data now, you can see it now. I now want to sort my total now. I want it to be from the highest to the lowest. So that is going to be in descending order. So how do I now sort that now? So this is where I'm now going to be using the sort values method. So the sort values method allows you to be able to sort your data based on a particular column. So now I'm going to be sorting by total now. So by default now, it is set at what? You can see it is set at ascending by default, which means what? It's going to be starting from the lowest value, then up to the what? The highest value. And you can also see the indexing has been shuffled because what? It is a sorted data that we're looking at now. It is sorting by total. So the indexing is going to be scattered. Unlike earlier on where the indexing, you can see it was from 0 to 999. But because we have already shuffled this, that is from total, the minimum total to the highest total, the index has already changed. So now by default, now it is in the ascending order. So if we want it to be in descending order, we have an argument called ascending. So I'm going to set ascending to false. So when you set ascending to false, you now have it in what? You have it in descending order. So what you just did now was by setting this ascending to false, I already tuned this what sort value to give you your data frame in descending order of total. You can also do in descending order of unit price. In descending order of unit price, you can also see that what the unit price now. You can see the unit price now, 66.62 up to the lowest. So this is what the sort values allows you to be able to do, to sort your data frame based on a particular column. So now from our sales data now, we have a column of product line. So that means we have the product line, but we don't know how many product line we have. Because now, currently now you can see miscellaneous, braking system, suspension and traction, frame and body, and engine. And you can also see electrical system, braking system, frame and body, and frame and body. But we cannot just say these are the product line we have. It's possible we have some product line which we are not currently viewing. So if you have a data of going to 1,000 rows, going to 10,000 rows, how do you now view this particular value so that I can know that, okay, these are the number of product line which I'm dealing with. So this is now where you now use the value counts function. So currently now, what I'm just going to do now, I will index my product line. So okay, this is my product line. Then I'm now going to apply the value counts method. So the value counts method now gives me the number of values under each particular, it gives me the number of values under each particular product. And also it allows me to also see the number of product line that I'm having. So under each product line, I can see how many transactions was made. You can see 230 transactions was made under braking system, 228 under suspension and traction, 193 under electrical system, 166 under frame and body, 122 under miscellaneous, and 61 under engine. And also now, any product line which you don't see here, then that means that product line is not inside your data frame. So, and all this product line in our data frame, that is why we are viewing it. And it's not going to give you any product line which is not in your data frame. So now currently, now you can see we are having 6 product line. And also have the values under each 6 product line. So this allows you to view, it allows you to view the number of the frequencies of your values in a particular column. I can change this product line and also see for that of payments. I want to know how many payment system do the organization use, and also the number of payments on the number of transactions under each particular payment system. You can see now, you can see that of credit card. So 659 under credit card, 225 under transfer, and 116. So this tells us that, okay, 659 transactions was made under credit card, which means most transactions were made from credit card. And then we now have transfer, then we also have cash, which is having fewer transactions. So this is what the value counts method allows you to do, to be able to check the number of times particular value occurs in a particular column, or the frequency of the values in the column. So now what if we now want to get the unique, although the value counts also allows us to see the unique values. So if I want to also get the unique values now, I can just, let's say, for example, the unique values now under, we have a column. Let's view the data again. So you can see now we have a column of warehouse. So let's see the unique values. We want to see, know how many warehouse do we have. So I'm going to use sales warehouse, then unique. So you can see it's now the number of unique values. We have central, we have northern, and also have west. So you can see these are the three warehouses that we have: central, northern, and west. So you can see. So if you're just looking at only this head, you think that we're having only two, central and north. So this is one thing what the unique allows you to do to get the unique values in a particular column. So even if a value occurs 100 times, the unique is going to count it as one, so that you're able to check all the values in that particular column. You can also check the length of this particular. You want to check because you can see now this is stored in a list, which means you can also access it the way you access other lists. So if I want to just access this now, I can just, let's say I use 2 now. You can see I'm going to be getting what west. So normally I would have just stored this as a variable and now use this particular 2, but you can still you can still index as a variable. I also want to get the length of this particular list now. Let's say it's product line I'm having now, product line. So but this is my product line. If I want to now get the length, I can use the length function. So this is the length function. So it allows me to be able to check the number of elements or items in my lists. So that's what the length function allows you to do. So now next we'll now be going to data aggregation. So data aggregation now allows you to be able to aggregate your data. So the first now we're going to be talking about describing your data. So you have your data sets now. You want to get a quick description of it. You want to know what's going on before you now proceed with any other further analysis to save you a lot of stress. So what I'm going to be doing, I'll be using the sales or describe. So you can see the sales describe. But if you go back to view our sales data now, sales.head, you can see that under the sales data, we have only 3 numeric columns: quantity, unit, price, and total. So this sales describe only describes numeric columns or numeric variables. So any other variable that is text or maybe another data type, so any other column, sorry, that is a text or another data type is not going to give you a summary of it or a description of it. So it only gives description based on numeric quantities or numeric columns. So now you can see that our column quantity, unit, price, and total are all present in this particular description. So the first now we have is the count. So in case this allows you to check whether you have missing values or not. In the case where you have missing value, let's say you have a single missing value on quantity, that means here is going to be what, 999 and not 1,000. Same thing also applies in unit price. Same thing also applies in total. So now you can see that what we have no missing values in this particular column. So you can see all through they're all what, 1,000. So this is the count. Next we now have the mean. So this is the average. You can see the average quantity is approximately 9.4. Average unit price is approximately 30.3, and average total is also approximately 289.1. Then next we also have the standard deviation. So this is the how much the particular value or particular quantity is deviated from the mean. So I see the standard deviation for quantity is approximately 9.7. For the unit price is approximately 12.3. For the total is approximately 345. So this allows you to be able to check the standard deviation of a particular column. They also have the minimum. So what is your minimum value? The minimum value now, or the minimum quantity now, was 1. So that means the minimum number of items that was bought was 1. And that's the minimum unit price is 10. So the minimum unit price for a particular item is 10. And also we have the minimum total is also what's approximately 10.4. Then also have our quartiles. You can see the first, second, and the third quartile. So the second quartile is also known as the mean. So here now we have 25% quartile, which is the first quartile. So which means that any transaction with quantity above 4 is above the first quartile. Then we also have the median here. Any transaction, any quantity that is above 6.5 is also above the median class. Then we also have the upper quartile. So any transaction that is above 10.0 in quantity falls in the upper quartile. Now you can also see that of the unit price too. Also the same thing also applies. Any transaction that is above 21 also falls in the first quartile. Any transaction above 28.6 falls in the second quartile, and any transaction above 37.9 also falls in the third quartile. So now this just allows you to know that this is like a benchmark. So this is like a benchmark to know that, okay, that means we have any transaction now that is like 40. If you have an item with unit price of 40 or unit price of 45, we now know that okay, this particular item now falls in the upper quartile. So that means among the most expensive items in terms of unit price. So this is what the quartile values allows you to be able to explain in your data. Then we have the maximum value, the maximum quantity of an item inside the transaction record, which is 40, the maximum unit price for an item, which is 66.6, and also the maximum total price for an item, which is 2,546. So these are information that describe method allows you to get, saving you a lot of stress and hassle when you are conducting your analysis. So you can actually create a report based on just these values that we're having here. So now we have what we have called crosstab. So crosstab allows you to see the relationship between two particular variables. So currently now I want to know the number of clients that are paid, the number of clients under each particular payment type. So I'm going to be using the pd.crosstab. So the crosstab method belongs to the pandas library. So that's why I'm going to be calling it using the pd.crosstab. Then I'll now, first of all, my client type, because I want to know the number of clients under each particular payment system. Then next is going to be my payment system, which is payments. So you can see now I have a crosstab showing me the relationship between these particular two variables. So you can see now that we have 116 retailers that paid through cash. We have 659 retailers that paid through credit card. We have 0 retailers that paid through transfer. We also have 0 and 0 wholesalers that paid through cash and credit card. Then we have 225 wholesalers that paid through transfer. So what this explains to you is that none of the wholesalers actually use any payment system apart from transfer. So all wholesalers actually use transfer. And this is understandable because wholesalers, they're the ones that are actually going to be paying more in terms of transaction. So it's not going to be easy to be paying by cash or paying by credit card. The best option for them will actually be the transfer. But you can see the retailers, most of the items they buy don't usually used to be much. If you go back now to this place, you can see that we have a minimum of even 10.35. So 10.35 actually something that someone can pay through cash or through credit card. And most of the items they buy are not that bulky. That's why you can see in terms of transfer payments, there are no retailers that actually paid through transfer. So this is just one possible crosstab which you can view. You can also have another crosstab of let's see, crosstab of let's say the warehouses. Okay, let's do it like this: client type, then product line. We'll do it like this: client type, then product line. So product line. Okay, I think it's easier if I just swap it. So product line is going to be here. Then here we have client type. It's better like this. So you can see now under each particular product line, you can see the number of clients that bought a particular product. So you can see that in terms of retailers now, you can see that most of the retailers actually bought suspension and traction and braking system. And also in terms of wholesalers too, most of them also bought the same thing: braking system, suspension and traction. But we actually know that the wholesalers are not much. So this is another possible crosstab which one can view. So this is just the count. It's just counting the number of transactions under braking system and retailers. So now what if you want to now filter your data? So you want to filter your data frame now based on a particular value. So we have sales. We have sales total. So this is our sales total. Now we want to check for what? Each row. We want to check if it is what? Greater than what? 1,000. Each row now, we're checking if it's greater than 1,000. It's going to be returning a Boolean value. So we discussed this in the first class, Boolean values. So you can see, okay, let me go back to it. You can see our row 1 is 134.83. And when we check if it is greater than 1,000, it returns what? False, false, false. So it's going to check it till the last row. So now we want to what? Filter our data frame based on this particular Boolean value. So this is where I'm going to come here, sales, then inside your square brackets, you can see it, then you close it. So now what this actually does is that what? It takes these particular Boolean values and check for it. It only returns the true values inside your data frame. So you can see that somewhat rows have been skipped because this is a filtered data frame. You can see row 5, 8, 46, because these are only the rows that meet this particular condition. it's only going to return what rows that meets this particular condition of what sales total greater than 1,000. You can see the sales total is each of them is greater than what 1,000. So I can actually just view the head. That's just the top 5. You can see it. So now you can see what our filtered data frame. So I can actually store this now inside a new variable and make use of it. So it's possible now when you're conducting your analysis now. It's possible that, okay, you're only conducting your analysis based on, let's say, you're conducting it based on, let's say, wholesalers. I'm just going to put this sales warehouse. Then warehouse is going to be equals to equality sign, please, not the assignment operator. It's going to be equals to central. Okay. So now any value it returns is going to be what those of what we are saying. You can now make an analysis based on only what central warehouse. Or let's say I'm only interested in wholesalers. So client types now. I can actually make client type to be wholesale. So wholesale. Now see, you only get what? You only get client type that are what wholesales. What if I now want to combine two conditions now? I want to combine client types that are wholesales and also what client wholesalers that bought engine. So okay, let's make it like this. Clients type that are wholesale and from the what northern warehouse. So I'm just going to put this in a bracket. So I'm going to put this in a bracket. Let me see. They will now give another condition. So this is the ampersand sign, the and symbol, will allow us to now give another condition, which will now become sales warehouse. Then warehouse is going to be equals to not. So let me just move the 8 for now. Okay. So now, okay. So this means that it seems we don't even have any transaction that is satisfying this particular command. Okay, let's try another one. Let's see central. Okay. Okay, let's change it to all. Let me see. Okay. Okay. So I forgot my brackets in this place. So now just make sure that in each condition is enclosed in a bracket. Each condition is going to be enclosed in a bracket. You can see it, each condition will be enclosed in a bracket. So now we're checking for what wholesalers and also from the central warehouse. So you can see now all our what condition have been met. So you're going to check your data frame for this condition and only filter values that are satisfying this particular condition. So this is how you can what filter your data set based on a specific value. So you can also see this particular one now is checking for what total greater than 1,000 and from the what central warehouse. So when you run this also, you get what your value. And also you can check for this one too also. You see this one is actually stored as a subset. So it's checked for what sales greater than 1,000 and sales that are also from the central warehouse. Then we also have the group by method. So group by method allows you to what group your what a particular variable. Like now you want to what let's say you want to get the total amount that was made under each product line. So I can say sales.group by. When I say sales.group by, then I now give my what client type column. Now see it's client type column. Then I now use what I also apply the what sum on it, sum of what total, because I want to get the total sales that was made under each client type. Then I now what run this. You can see what's the total under each what client type. You can see my total that I'm having now. So actually subset is total since I'm interested in only total. Okay. Or let me just do it like this. Use the log function. Can use the log function. Do it like this. Then it's going to be Okay, sorry. So let's try and store this as a variable. So let's see, we'll store it as a grouped clients. So we have our grouped clients, store it as a. So these are grouped clients now, and we want only the total column. So we want only the total column. We can use the log function now. This dots. Let me see dots then. Okay, let's just do this. Okay. Don't know why it's returning an error. So just leave it as that. Okay, let's say we want to now apply two groupings now. We want to group by sales.group by then let's group by product line. Then under each product line, we group by the, let's say we group by the client type under each particular product line. Then we also group by the payments under each particular product line. Then the sum of the what's total. So you can see it now. So under each particular what's product line now, you can see it. Or let me just even change this. Let me just do this. Okay. So you can see now under each particular what's product line, we have the payment system that was made. And under each payment system, we also have the client that was made. And you know that most of what the clients that got most of the clients that bought items through transfer are wholesalers. Then those that bought through cash and credit card are retailers. So that's why I can see retail and retail under what's cash and credit card. You can see we grouped by product line first, then we now grouped by payments, then we now grouped by client type. So we now have the quantity, the unit price, and also what the total. You can see it now under each of these particular grouping. So now braking system, cash and retail, these are the values which you are going to be having. And braking system, credit card and retail, this is what you're going to be having. Braking system, transfer and wholesale, then this is what you're now going to be having. So that's how you can use the group by method on your data frame. So next we'll now be talking about is visualization. So we have visualization libraries which you can use as a data analyst. We have Matplotlib, we have Plotly, we have Seaborn, we have a lot of them. But Pandas also has its default visualization functions, which you can also use to explore your data set. So currently now, if I want to now check I want to see the number of transactions that was made under each particular product line. Say sales.product line. So I'm going to say my data sets, then the column I'm interested in, which is product line, then dot value counts. So counts how many transactions was made under each particular product line, then plots, then kind is equals to bar. So this is going to give me a bar chart. So you can see now that I'm having this or below the code I have. So this Matplotlib in line, which I have earlier on, if I don't actually have this run in my notebook, then my plot is going to be shown in another tab. So you can see now, I can now see my product line and the counts of each particular product line. You can see that our braking system is the highest, followed by suspension and traction, electrical system, frame and body, miscellaneous, and also what engine system. So these I can now view for a particular column in your data. I can visualize a particular column in your data. So what if I now also want to make, we want to now change it to a pie chart now. I can actually change this bar to pie. You can see now I'm now having a pie chart. You can see the suspension and traction, braking system, engine, miscellaneous, frame and body, and also the electrical system. So you can actually switch between any of these particular charts. But one thing with the Pandas visualization function that it's actually limited. So it's not as flexible as other ones. But in terms of you want to perform a real life analysis, it's advisable to use other visualization libraries which are much more efficient than that of the Pandas, because this is not actually the Pandas sole aim for visualization. So this function is there to allow you to perform quick plots or quick visualizations. The Panda is actually meant for cleaning data, analyzing data, transforming data. So now what if I want to now get the total, I want to get the total payment that was made under each. So under each warehouse. So I'm going to be grouping by warehouse. I want to visualize it now. The total payment under each warehouse. I'm going to be grouping by warehouse, then total. You can see it. So if I run this now, so this is my warehouse total. Then I'm now going to be adding the aggregates, which is mp.sum. You can see what I have now. You can see the aggregates now, mp.sum. Then I'll now add my plots, which is going to be a bar. So you can see it now. This is the total amount that was made under each particular product line. What if I now want to get the average unit price under each under each payment system? What if I now want to get the average unit price under each particular product line? I'm now going to be using the product line dot value counts. See, then dot plots. Then kind is equal to pi. Okay, sorry. I'm supposed to use the group by. I'm supposed to group it by product line. The product line, then I'm interested in the unit price. The unit price, then aggregate is going to be what? So mp.sum, this mp is from the NumPy library. So allows you to access the sum function in the NumPy library. So we're summing the unit price. We're summing the unit price. So I actually want to even get the average self, not the sum. So the average unit price, then plots. So kind is equals to bar. So to run this now. So you can see what we have now. You can see what you cannot be able to see which particular unit product line have the highest unit price. You can see the highest unit price belongs to engine, followed by frame and body. You can see followed by frame and body, followed by miscellaneous, followed by suspension and traction, followed by electrical system. Followed by electrical system, then followed by suspension and traction, then electrical system, then miscellaneous, then we now have braking system. So the highest unit price belongs to engine, then we now have that of frame and body, then others are also following. So you can see this is the second to the last, and it's also the last product line. So this is all for the visualization using pandas function, and this is going to also mark to an end to our class, data analysis with Python. So this case study is going to actually mark the end of it. So in terms of creating more flexible visualization and more comprehensive visualization, use visualization like Plotly or Matplotlib or Seaborn. So Seaborn, you can use it to create statistical visualization. You want to visualize statistical diagrams, use the Seaborn library. If you want to create interactive visualizations, which users can interact with, and they can actually use their mouse and cursor to actually filter. This, you now use the Plotly library. They also have basic visualization like this one, because these functions were created on Matplotlib, so they're also similar to plots which you can find in Matplotlib, because the pandas visualization functions was built on Matplotlib. So the Matplotlib is actually the fundamental visualization library in Python. Then we now have others too. So we have a lot of visualization libraries. It depends on your use case and also your preference. So I don't know if there's any questions from the class. So hello.
Hi, sir.
Any questions?
I don't think there is any question. Just
Okay.
for us to go through it and really ruminate on it and get one or two things back, because I can see you are a specialist on it, and the way you are, bringing in the codes and the is so engaging, so engaging.
Thank you.
We need to go back to it and check it one by one in order for us to get conversant with all the plot kind, this type, and some other things like that. You understand, sir?
No problem. The recording will be available by tomorrow morning, so you can just go through it and have a glance at it.
Yes.
That's a good one. So and also it's important you ensure you have the libraries installed before you start. Because if you don't have them installed and loaded, you cannot work with it. And also, I don't know if you have the files for the data set, so you can work with it also.
We are going to give us this file, right?
Yes, we are going to give you the file. Don't worry, I will share it.
Okay.
Yes, I will share it.
Please do, sir.
I'll share it. If I maybe let me do that in the chat set now.
Thank you very much, sir. Thank you, sir.
So this all for our class data analysis with Python. So I'm going to be sharing the link now to the file. That's the file where you download it from.
I please don't forget to send your contact details.
Okay, don't worry, we will.
Yeah, we kind of group training and some other stuff like that that we can invite you.
Okay. Our paid class is going to be available by March, and we hope to see you there. Actually, check for more details from our sites. So,
okay.
Yes, so we hope to see you there. I also hope to get a good review from you also.
I will definitely do. Just keep
so
1 weekend. One weekend like this, I think I will. I just and get you.
Okay.
Thank you very much, sir. Thank you for your time. Thank you for the training. What's the time?
Hi, Mr. Khalid. Is there any questions? Mr. Khalid there. Hi, Mr. Khalid. Okay. So let me see if I can actually share the link to the. Let me see if I can actually share the link to the files. So it's actually on GitHub. So I don't know. Mr. Adedamola, have you heard of GitHub?
Yes, yes, one of the, I don't know if you are the one that uploaded the first, was it the first training or something?
Yeah. So I'm actually going to share the link to the folder on GitHub. So if I share the link now, you can access the data there, and also you can download the data from there, and you can also download the. Okay, let me actually share the screen back. So.
Thank you very much, sir. Appreciate that.
You can see currently now this is GitHub, so you can see the IPYMB is a Jupyter notebook. So when you see IPYMB, it's a Jupyter notebook. So these are the files which you are going to be using. So you can see Python fundamentals. This is the day 1 and the day 2. Why case study.ipymb is the what? This is the case study I will just treated today. You can try open it and view it.
Okay, I will do. And if there is any I encounter issues, I'll get in touch with you.
Yes, no problem. You can just hit us up. No problem.
Very much, sir.
So it's actually going to take time to load. You can just download it here. I think it's this button, right? Oh, there's actually a button for downloading. I'm trying to see it. Let me see. So I don't know. I think it's from the back. So this is the Jupyter notebook. So this is the Jupyter notebook. Then the data set sales.csv. So you also have the access to the data set here. You can see the sales.csv data sets. Motorcycle sales. So you can see the data set here. So this is the data set for the motorcycle data set. So all is on the
Stop.
there. You can just thank you everyone for joining the class. Thank you, Mr. Adidamola. Thank you for any problem. You
Thank you
can
very much,
feel
sir.
free to hit us up. And also
David,
our class on R2 is going to be next week. If you are interested on learning the R programming language also, you can
okay.
join our next week's class. You can register for next week's class also.
Okay.
And we also have another cohort too that's going to be coming up February. So it's another cohort. We're also going to be taking Power BI, Python, and also the R programming language. That's for February classes. So
Okay. Understand, sir. Thank you very much, sir.
we also have interest in Mr. Adidamola, Mr. Khalid, Power. So it was nice meeting you people and also having a okay. So I think that's all now, Faida.